Yep, thank you. So, yeah, as I was introduced as computer vision and MLOps engineer, I will be talking about none of those things today, of course, because, why would I? I would be talking about coding agents and AI agents in general. Now, throughout the talk, I will be interchangeably use both terms, AI agents and AI coding agent, just because the things which I will be talking about today and that which I will be showing today are essentially can be applied to both AI agents in general, but also to AI coding agents specifically. The only difference would be some of the tasks which agent would be doing, but I will talk about this later. Now, before we actually dive into the agentic world, I want to ask you one thing. So, what do you think? Do developers spend most of their time during their work? And spoiler alert, it was coffee. So, any ideas? Okay, reading. Okay, me. I got meetings somewhere. Any deploying? Okay, debugging. Yeah, that's yeah. I guess all of that can actually be, I guess, combined into the understanding part, right? So, I know this research was done in 2015 with 10 years ago, and I think it's still kind of relevant, even more than ever. Especially considering that nowadays you can, with the help of AI, essentially tap, get a lot of code, get 10,000 lines code, and then spend a couple days debugging whatever LLM produced for you, right? And current sort of generation of tools essentially focus on those 5% for us, right? They don't help us usually understand anything. They don't help us. They don't definitely don't help us outside of IDE, right? If you're talking about Copilot or Cursor or whatever, right? They are focused inside the IDE. They don't go outside of that. Uh, yeah, interaction as well to some extent, but again, the main sort of time-consuming parts, right, for us, for the developer, is understanding, and this is the part where current coding systems are lacking, right? No, I'm saying there are a few. Now, of course, yeah, I guess I'm telling the truth. Now, the the thing that can help us with that is, as you would guess from the topic of the talk today, is AI agent. Now, AI agent can essentially be defined as a software that performs tasks on behalf of a user. You might say that this kind of sounds like pretty much the same as the current code assistant, right? So you essentially give them a task, all right? You can ask them to generate unit tests for you, and they hopefully perform good. They hopefully generate some tests for you, which you could use. Maybe they will work or not, if you know. Um, the difference is, unlike like general software, AI agents follow a specific sort of patterns or principles to you. First one is tool use, so they can essentially use any tool at their disposal, like in a web search. They can do they can execute code. Um, they can connect to some web servers and so on. So basically, they can essentially use any tools at their disposal. They can also reflect, so they can critique their work or the work of other agents. They can also do playing. Um, so they can basically execute some thinking process, plan ahead, plan some steps for performing the work, and then of course they can also collaborate with each other, right? So I already mentioned the ability to reflect or to critique each other, and in general, they can in some way interact with each other. Um, Help each other or solve tasks delegated from other agents, for example. Now you can think of a Roomba, of a robot vacuum cleaner as sort of an agent, right? There is a software on the vacuum cleaner which is essentially an agent. Its task is to perform cleaning of your house, of your floor, but without any tools, without playing, it would be pretty useless, right? So it will be just a software that if you can clean on its own. It needs some brushes, it needs some LiDAR scanners to do the playing, it needs some wheels to walk around. So basically, in a sense, Roomba is an AI agent which follow most of those patterns. It doesn't collaborate with anyone, well, apart from you, I guess, but still. And now if you go back to that slide over here, right, with this time distribution of the development time, we can actually see that all of those patterns, all of those agentic patterns are kind of overlapping. So we have the tool use, right? So for the tools, of course, we use IDs. We use browsers to search for something, right? To ask questions on Stack Overflow or whatnot. UI interactions also falls into the tool use in a sense. There is, of course, planning. And for planning, we do need to understand the task. We do need to understand the code. We need to, well, probably also spend some time outside of IDE, I guess. Um, there is, of course, reflection, which also based on our understanding of the projects and our understanding of each other, right? So we can talk with our peers, which also goes into the multi-agent collaboration. Potentially, we can talk with each other. We can talk with our teammates, discuss our plans, reflect on them, come up with a better solution, and so on. So essentially, if we want kind of good assistant, AI system, ideally we want to have an army of virtual AI agents, which would help us across all the steps of the way. Now, this kind of also uh, hmm, falls into these news articles, which you probably seen a lot of, right? So things like this, where this new tool will finally, or not finally, or it will soon replace developers, right? So in this case, it is about Devin, who I think it was last year where they came out with the notion of first virtual software engineer, right? Or what they call army of junior engineers. And of course, there is also a quote on Mark Zuckerberg, who plans to replace even already mid-level engineers soon. Now today, we will go into, we will see how we can actually, you can actually implement pretty much the same tools, pretty much the same agentic behavior, and well, hopefully, replace each other. Basically, we will write an AI which potentially can replace each other, replace us in the future, or maybe not. We will actually, if time permits, we will talk a bit about it at the end. But for now, let's actually go straight into the apply coding session, and all the code which I will be showing here today is available on this link. If you want, you can the QR code. It is publicly available, so if you want to experiment on your own after the talk, feel free to fork it, feel free to clone it, and explore. And throughout this coding session, we will go through several stages, and hopefully not those stages, but we'll see. Let's get back to this QR code. But basically, we will go through several stages, and I like to go through start from sort of baseline, from the most basic blocks. Right, so we will start actually from the most basic LLM, OpenAI's ChatGPT, and then we will gradually build on top of that. We will introduce tools, we will introduce reflection, planning, and multi-agent collaboration. I will go through all of those things step by step. Now let me switch here to, where's my mouse? Let me fit to our baseline code and what they zone means here. So all of the code is in Python, and if you don't know Python, no need to worry. It's pretty straightforward. There is not much of the difficult concepts here in terms of the code itself. And here, this baseline code, it is pretty straightforward. We are just calling the LLM. In this case, it's the OpenAI's GPT-4 Turbo. And if you played around with it, you probably know that we can't access any tools like browser. Well, there are some modifications now which allows it to do it, but sort of vanilla GPT-4 can't do any of those. So if we just try to, let's say, ask it to ping the Google, essentially, right, it will, and if Wi-Fi permitted. Let's see. So basically, of course, we won't be able to, yeah, indeed, it is unable to ping Google or any website for that matter. It is, of course, also not able to access my local machine. It can give me, well, in this case, my Python packages, It does provide some help on the potential commands which can help me, but it can't, essentially execute them. And then for Python 14 is supposed to come out, I think, in a couple months. And unfortunately, the model was trained, I think, it doesn't mention it here, but I think the last training day was 2023. So of course, I don't have any knowledge about Python 3.14 or for the Python 3.30 for that matter. And this, of course, not very helpful, especially if we are talking about us before asking to perform ChatGPT any coding tasks, right? Especially if we, for example, use some sort of internal frameworks, we have some company frameworks, ChatGPT have no knowledge about them, and it can't really give you the good quality code without such knowledge. Now let's see what we can do about that. And third, we will let me see here. First, we will do the easiest agentic behavior we can produce. And for that, we will be using what is called React framework. So React stands for reason and act, and it basically instructs LLM. In this case, again, it will be ChatGPT. It basically instructs LLM to sort of perform its actions in a loop of think and action. So essentially, it will go through several stages. It will first do the thinking process. It will then choose an action, and the type of action is defined later in the form. Then it will pause, and during the pause, the action is supposed to run and give the LLM the result of its execution. And then there is observation step, where LLM essentially checks the output of the action, and then based on that output, it hopefully gives us an answer. Or if there is not enough information, it will try to use another tool. Basically go through this loop again and again. There is some attraction on how to call the tools, right? And in this case, we will define a few tools. We will define ping, right? Which basically, as the name suggests, it will ping the web type. We will define bash command, which will basically run any bash command. And obviously, don't blindly try to run any bash command if not safe. But for the sake of this presentation, it hopefully should define. And then we will do web search, which will allow LLM to do any web search. Now, and here also we also provide some examples on how LLM is supposed to give us sort of a sign on which tool it won't need, right? So if LLM wants to perform action of think, it should output the line, right? So ping, semicolon, and the web type. Then go for bash and web tool. There are also some example sessions for LLM to better understand what we want from LLM, what we want to get from LLM. So yeah, all of it pretty straightforward, right? There's nothing too painful here. So let's see how these can now help us with our quest to better coordinate systems. So it's pretty much the same query model. We have three of our commands defined, mentioned before, right? It's a think, it's a bash, and we have web search. Let's test them out. So ping works pretty nicely. Python, yeah, I have 3.12.6, and the vector also seems to work. So let's now try to use the whole thing with our OpenAI ChatGPT. Here, I'm basically defining the query function, which essentially will run the loop of React framework, right? So, and we will limit max iteration to 5, just to avoid any potential infinite loop. So it is again pretty straightforward. We will query the model. If the model decides to call any specific action, we will detect it through regex method, and then we will execute that action. And then hopefully we will either get an answer or we will go to the second loop and so on. So let's test it out and see how it works out. So the response time for Google. Okay, so the thought LLM decided that it needs to call the ping command, which make sense, right? So it got the derivation. In this case, it's 8 milliseconds. all is good. And the same should work again for the fighting packages, right? So he decided to call the bash command, please. Gets out sort of the please. It is pretty long in my case. And then LLM got a stancer essentially, right? So in this case, it's sort of a summary. And the same for the Python 3.14. It did the web search, it got the data, quite a lot of data. Yeah, and there is our answer. So the answer from LLM, it essentially summarized for us the web page, right? So of course, basically, whatever action you can program, whatever action you can define, can potentially be run by LLM. So those are the simple actions, but you can imagine something more complicated, and we will see some examples going forward. Now, of course, you could build on top of that, right? So you can define your own tools through Python, for example, in this case, so whatever language you prefer, you can put them one by one through this sort of same pattern into the prompt. But that, of course, not very convenient when we are talking about having, hundreds of tools, right? This is where MCP comes from. MCP stands for Model Context Protocol, which was introduced by Anthropic, I think in November 2024. And it is pretty forward. So what it does for us, it introduces three top concepts. We have MCP host or MCP client. In this case, it could be either our ID, it could be our Python script, it could be whatever, any client which want to use the tools as part of its LLM call. And it also has MCP server. MCP server again can also is essentially any tool, any server to which you can define yourself, or which you can, or any community provided servers, which I will show later. And they communicate with each other through MCP protocol, which is essentially just a structured input and output, along with some syntactic sugar, which helps AI or LLM models to get the list of tools, get the way of usage of those tools, and so on. So basically, it's just essentially pydantic based structure. If you are familiar with pydantic, you can of course program them yourself. But why bother? We already have this MCP, and it's pretty straightforward. Again, MCP servers can either be trigger some local resources, MCP servers can trigger web APIs or whatnot. So essentially, again, whatever you can imagine, whatever you can program, can be converted into MCP server. Now let's go back to our idea. And there is, of course, a lot of MCP community supply servers. There's a small part of it. So there is hundreds of servers which you can find in the Tito Model Context Protocol repository. And they are available for pretty much anything you can imagine, right? So there are Kubernetes servers, Jira servers, and so on. So basically, any tool imagine this. Now, of course, if you didn't find a server which you might find useful, you can also do that yourself. And it is pretty straightforward. So here we are defining again the bash tool. In this case, it is defined as a server. And as you can see, trees again pretty straightforward. We can use this pass MCP plus from MCP package, which basically just is an MCP server for us, and we don't need to worry about anything else. We just need to define our tools, and that's pretty much it. Right. So in this case, again, it's a tool which will allow LLM to call bash. That's pretty straightforward. Now look at how can we use that in our AI call. So in this case, I will switch to Claude, to the model from Anthropic, just because Claude initially was trained, well, not initially, it was particularly trained to perform better with tool calling. So it works better when we are talking about the tool usage. However, as you've seen before, you can also easily use that with OpenAI if you prefer OpenAI. But for the sake of the demo, I will be switching to Claude just because it is more convenient to use that model with the tools. Otherwise, it is very straightforward. Again, we in this case we are acting as a client and CB client. We are defining some way for the client to read the servers from the JSON config, and I will follow it up in the backend. And then we just brought the query. Again, we are basically just consuming the user input and then sending that input to LLM along with the list of tools available for its use. And then we will perform the action is the LLM will decide to do the tool use. Over here, so basically the model, if the Claude, the Sonnet model, will decide to do the tool use, it will provide us with this structured output with the type of tool use, and then it will also give us the name, the input to the tool, and so on. And all of those things, name, input, and whatnot, are provided automatically from the NCP server, which is nice because you don't need to worry about, again, going back to these previous fronts, you don't need to worry about defining all of that as part of the front manually. Then we call them execution, and that pretty much it. Then there is some system teaching things about calling the Anthropic, but that's, just the typical stuff. And then, of course, we'll go into the chat loop, where we'll get the query from the user, and then call our LLM. All that is pretty straightforward. Now, the way we define our servers for LLM to use is through this JSON file, where we can basically just show the clients what kind of soap we kept and how to run them. So in this case, we just run Python script. So we can use Python command with the file name, but of course you can essentially run any server in any format imaginable. Usually they come as either files packages, JavaScript packages, or Docker images. So with a full JSON, we can key all of the options here. So we will have file system access, which is run through npx. So basically it's JavaScript or TypeScript package. We will have brain search, which is run a Docker image. We will have patch for URL patchen, which is run of Python, and we will have our bash tool, which is help to run a Python file. So it is, again, essentially pretty straightforward. You don't need to worry, again, about defining any of those manually for LLM to use. They are provided as such command and args. That's pretty much it. Now let's see how they will work in action. So let's start with our bash tool first. So yeah, it wants us to ask something. So let's see all files. Then hopefully again Anthropic will be stable enough to get the answer, because lately he's been acting out. So yeah, looks like everything's fine. So Sonnet model decided to call the bash tool, which makes sense, with the command ls-la. It got the answer over here, right? And then some other comments as well, which is nice. But then let's try all the tools we already have. We have, just as a reminder, we have access to file system. We can do the web search. We can patch some URLs, and we of course have bash tool. So let's try something. Who are Peter on the drips on the radar? Fight. Let's see if Claude will be able to find this information for us. Okay, so it has to do the search for the Wiki database choice. Seems like I didn't find the list of speakers, unfortunately. But yeah, probably if this would do some follow-up, it would be able to find it. Let's test the Python find question. Item. I think this would be easier for LLM to find, because there is a dedicated page for that. Yeah. So yeah. Yes. I guess Claude decided that there is only one major feature for Python 3.14, unlike ChatGPT, but well, it is what is it. And of course, we can also, because we have the access to the file system, we can also ask Claude to create files or do whatever manipulation with the file system we want. So let's ask it to create a new file. Create a new file named hello 50 with text hello world. All right. So it decided to call the write file tool, which makes sense. So it provided some JavaScript code summary, but it's, I guess, already been very mouthful. And let's see. So yeah, indeed we have the new file, hello.tc, was created 17 seconds ago. It contains what we asked it to do. All right. So now you can probably already imagining those tools be not just the tools, not just the bash commands or whatever, but also agents on their own. All right. So you can think of sort of agent calling another agent or delegating the task to another agent and them working together to perform some action on your behalf. This is where you're going into the multi-agent information. So basically, what we will be doing today in the short demo today is this kind of schema where we have a supervisor agent who will be acting as a liaison between three other subordinate agents, namely front-end developer, back-end developer, and DevOps engineer. Now, of course, you don't need to humanize them, right? Obviously, LLM doesn't have a notion of front-end or back-end engineer, but it is good to make them more focused because I would imagine that front-end engineer and back-end engineer would require different set of tools. So it would be better for each separate agent to have its own dedicated set of tools instead of the whole set of all the tools, because otherwise they can get confused and they can go into potentially infinite loops, which we don't want to have. Now let's see what they can come up for us today. Not this one, multi-agent. Yeah, multi. So in this case, I will be switching to a land graph from LangChain. It is again sort of another abstraction on top of Floody and MTP. And again, you can define all of the inter agent collaborations yourself. It is pretty straightforward, but again, there is a lot of nice libraries which can help you do that easily. So in this case, we will use LangGraph. We will again use Anthropic, and we will define pretty much the same tools. We will have shell tool, we will have a search, and we will have file management, which is essentially file system access. We will also add one other thing which wasn't there before, which is a human tool. So not tool, but basically it will allow LLM to ask any questions back to us. So if it requires any clarifications, if it requires any answers to any questions, it will be able to ask us instead of us asking it. Okay. And then we are pretty much defining all of our team member over here, right? So we have supervisor. It has all of the available tools. You can ask human, and then that's pretty much all that we need to define our supervisor. The same goes with the with our front end, back end, and DevOps engineers. It is again pretty much the same React loop which we've seen before, focused on the specific tasks. Like it's the front end developer, right? It can ask backend developer for help, or DevOps engineer, or it can ask for clarifications from the client. And the same goes for the backends and DevOps agent or engineer, right? And as you can see, it is pretty much just a few lines of code. And all of the time they report back to supervisor with this is, but then again, of course, you can also define them to be able to talk to each other as well. And then we are essentially using a graph of the interaction which you've seen before. Now let's check out this graph. Yeah, so we have a supervisor as an endpoint, which can interact with our virtual developer, front-end, back-end, and DevOps. Or it can also decide to finish if supervisor decide that the task is done. And then let's try to run a rather simple task. In this case, we want to build a website for a conference. It will have several pages. We want to have backend, I think in Fast API. Frontend should be in React. We will use PostgreSQL as database. So pretty rather broad, but pretty straightforward at the same time requirement, right? So something you could get from your product manager, I guess. And let's see how our multi-agent system will tackle it up. So supervisor decided to call the front-end developer first. It, I guess, makes sense. Then in turn, front-end developer is asking us in turn on sample applications. So, as a good product manager, we will tell it to figure it out itself. Build out yourself. Got Y button. All right. Okay, so yeah, I decided to use the React frontend framework. We interacted. It decided that it wants to use this the React app framework, and I think this will take some time. So I think it could already preview some of the develop. Yeah, so we already have this conference website. The package is done. I think NPM and SAL will take some time because yeah, they usually do. So while it's doing a thing, let's be how long to build. Okay, but we can leave it running for now, and we'll check it out later and see what it comes up page. And in the meantime, let's go back to our site. Now, of course, as I said, you can define all of those things yourself, and they're pretty fun to play with them, play around with them. But of course, you can also skip all the hassle and use all of those inside the ID with the app encoder. So I'm from encoder, so it wouldn't I wouldn't I would love to also from what our tool be. We are essentially a plugin. Yeah, so you can talk or even agents essentially without any effort. And I think we are kind of short already on time. So I will briefly go through your site. We already have a bunch of agents defined as part of our tool. You can install either on VS Code or JetBrains IDs. We are also introducing MCP integrations, so you will be able to essentially do all the things we did right now by defining your own servers or using community provided server and use them right inside the ID. I hope the quality of the video is here. Good enough? Yeah, okay, better. So basically you define your own servers. In this case, I'm using a pretty straightforward simple server which checks the current time, but again, you can use whatever you want. And then right inside the ID, I can essentially use or leverage those agents to get any interpreter from the conference encoder. In this case, of course, it is pretty straightforward. It will just check the time. Yeah, so it will call the tool, get current time, and it will get this time. Oh, yeah. Oh, yeah, it was recorded pretty later, but all right. Yeah. So, and one interesting tool which I found actually while I was preparing the bike is this Netherlands railway system tool integration, where basically you can call Netherlands railway servers and ask questions like this. So essentially, you would be able to connect this to your ID and ask, right from ID when is train to until over there. So let's quickly check what we have to the data inside. Pink npm still running, but we should get some of the. Okay, yeah, I think probably connection is not that fast for npm to run, so unfortunately we won't be able to give the full website. I should probably prepare some backup plan for that case, but yeah, usually depending on the website on the Wi-Fi speed, it can be indeed quite poor. Now with that, okay, we have 5 minutes left. So I will go quickly into what top of these agents bring us, and then we will go into Q&A. So, in general, I would say there are now two main type of sides or two main teams, depending on how you want to call it. So, one is saying that, okay, we will soon be replaced finally, or maybe, depending on how you want to look at it, by AI. And maybe you can go finally be a good farmer, whatever your dream is, right? Want to get replaced. Uh, but at the same time, of course, at least for now, AI can't live without anybody producing the data. So there is at least this job, well, right? But of course, in reality, I think at least we as a company, what we view the future, at least for the next 10 years, you would take, is us developers being transitioning to a more managerial role and having this sort of army of virtual helpers, virtual developer, to which you can delegate some repetitive or boring tasks. Then you, on the other hand, can focus on more creative, on more high-level tasks. So essentially, you being I guess, a product manager of an army of virtual developers. And with that, yeah, there are a few QR codes. So on the left, you can QR code for our website. You can try us out, and then the right one is for all of my contact information if you want to ask any questions or the interaction and whatnot. And with that, yeah, happy to answer any questions.